Everyone. So in this video, let us see important interview programs from 2D arrays. So called spiral matrix from leetcode platform. So that is program number 54. So which is from medium level. So actually first I'll type and execute this program. So in Jupyter Notebook platform. So later on, so what changes are required in the leetcode platform? So finally, so I'll explain and execute the program. Okay. So first, let us see the problem statement, and so after that, let us see how to implement it with the help of some sample input. Okay. So observe this, everyone. First of all, some n by n matrix is given here. That is rectangular matrix. So we need to return all the elements of so matrix in spiral order. Okay. So this is the spiral order. So means first row, so last column, so last row, and first column. Likewise, it has to be repeated in the so internal rows and columns also. Okay. So with the help of second example, also you can understood that it is a rectangular matrix is given here. So we need to print the values in that spiral matrix form. Okay. So it is so given here from arrays matrix, and so some hints are also given. So how to design so the program for this one I'll explain. After that, actually similar questions are given. So spiral matrix 2, 3, and 4. So you try it, okay? So to design so solutions for that. So I'll explain with the help of some sample example. Okay. Actually, so this one we can finish with so two-pointer approach here. Okay. So that is observe this example. Let us take so this one. Okay, so here three rows, four columns are given. Row size is three, and so the column size is four. Okay, so here, so we should take two pointers for rows and two pointers for columns. Okay, totally we are going to work with four variables, but at any particular instance of time, so we are going to work with only two variables. Okay, we can consider this one as so two pointer approach. Okay, so program next. Now let us see so how to design it. Okay. So first, so I'm going to take so two pointers for rows and columns. For beginning rows and beginning columns, I'm taking two pointers here. So m for rows, initially I'm taking to 0. N for columns, I'm taking to 0. Okay. So R and C variables acts as ending row and column pointers, and here, so M and N so variables acts as beginning row and column pointers. Okay, hope you understood. With the help of this, we are going to design. Regularly, we take so condition like this while loop condition for two pointer approach until start meets the end pointer. Okay, we keep on repeat the loop. Okay, so main programs you observe this condition. But here, so two so row pointers and two column pointers were there. So that's why. So how we can take the condition? So up to here I'll explain. No, up to here I'll type. Okay. So all of you have a look at once. Okay. So first I'm taking some so matrix here. Actually, in platform, so different inputs are going to be passed, okay? So it is going to be executed. First, I'll show you, so for this sample, so matrix, okay? So what we are doing, so row column, so M and N, 3 comma 4 and 0 comma 0, right? Okay, we take at this. And what is the condition here? So we have two row pointers, two column pointers we have, okay? So until until initial row pointer meets to the ending row pointer, we should repeat the loop. And until initial column pointer so meets the ending column pointer, we should repeat the loop. This is the so condition for so spiral matrix here. Okay. Now, so let us start design. Just the thing is here, only we should work on so how to print first row, last column, last row, and first column values. Only four loops we need to focus. Okay. So you should not think so how to design so the program for all the internal rows and columns. Okay. If you think like that, it becomes complex and it is not possible to design. Okay. So whatever the program we are going to design, so for so beginning rows beginning columns and ending rows and ending columns. So same loops should print internal rows and columns also. Okay. In order to print like that, so we should not design so the loops for the values, okay? If we design so for the variables, okay? Here we taken some four variables, right? If we design for variables, so variable values changes, right? It's not fixed, okay? So it's going to work for so the internal rows and columns also. How is it possible? Let us see now, okay? Actually, two forward directions, so loops now you are going to observe, okay? So for first row and last column, and so for printing last row and so the first column, you are going to observe the reverse loop. Okay. Next, two reverse loops and two forward direction loops you are going to observe now. Okay. So most of the programs, so I repeated that. So with the help of positions, we can print so matrix values, so matrix programs easily can design. Okay, same approach I'll follow here also. Okay, so first we should print. Let us focus on only the first row. Okay, don't think about all this at a time. Just focus on the first row. Okay, so observe what values we need to print here. So that is 0, 0 position, 0, 1 position, 0, 2 position, and 0, 3 positions. Okay, initially, so whatever the loop we are going to take, okay, it should print so these values. So next time, so the same loop should print the so internal row values called so 6 and 7. First time it's printing, so it is going to print four values, right? Next time it should print so go for two values. In order to work like that, okay, so we need to make use of these variables, okay, for running loops or else for printing values and subscripts also you need to use this, okay. So I'll explain now. So have a look at this. If you observe these positions carefully, you can understand one thing. So the first subscript value is fixed here. So that is 0, okay. So here, so it is the beginning row, right? Okay. What is the pointer we taken so for beginning row? So that is M, right? Okay. So means instead of taking so row subscript value 0, so we should take so the M variable value. Okay. Let us consider this is array and so in first subscript we need to take so M variable. What happens? It substitutes 0 only. There is no problem in it. Okay. And next to that, if you observe the column subscript values, you can notice one thing 0, 1, 2, 3. That is simply so the column loop should generate. So loop should generate so the values from the beginning column to the ending column. Okay. So what is the instead of running the loop, so in between so the 0 and 3, if you run up to from 0 to 3, it is limited. So to the beginning row only. Okay. Should work so for internal rows also, right? Okay. So in order to so work with internal rows and columns also, we need to take so the pointers, okay, in the loop. So what is the initial column pointer n? What is n variable value 0? So it should generate values up to the 3. That is last column. What is the ending column? So a variable pointer that is c. C value is 4. If we take so the stop position value as 4, okay, it is going to generate values up to 3, right? Okay. So after generating so the loop, so that the loop variable value on substituting so the column subscript, okay. So these position values are going to be printed, okay. So I hope you understood. After that, so we should move on to the printing. So the first row values, right? From first row onwards up to the ending row, we need to print. It's not required to so work with the first row again. Okay. So in two-pointer approach, same thing you can observe once after completion of working with any positions or else any rows. Again and again, it's not required to move on to those positions or else rows. Okay. So we are going to update the so row pointer here. Okay. So means beginning row pointer. So we should move on to the next row, right? Okay. So it's not required to work with the beginning row. So that's why M variable value. Observe here, M variable value we need to change to 1 after completion of printing. So the first row values. Let us complete this process first of all. I'll divide so programs into four partitions here so that you can clearly understand. Okay. So for in range of, so observe here I am running so the loop from so beginning column to so the ending column. Okay, and next so I am printing so array values, m variable value is 0 and next of all in I variable we are getting so the all column positions. In between values I am adding space. After completion of printing first row values, it's not required to work with that. I'm incrementing so m value by 1. Okay, so that's it. Hope you understood the first loop now. Now let us move on to the so next how to print the last column values. Okay, again so the same format. Let us take the positions now. Okay, so observe the 8 value position here. It is 1 3 and so 12 position 12 value position is 2 3. Okay, so if you observe, you can notice one thing now. So that is column subscript value is fixed now. So that is 3 value. Okay. So what column values we need to print now? Last column, right? Okay. So what is the pointer we have? So for last column, that is C. What is C value? It's 4. Okay. So from so 4 value, how we can retrieve so the 3 with the help by subtracting 1, right? Okay. So means in so column subscript in column subscript on taking so the C minus 1, okay, it's fixed, right? Okay, so 4 minus 1 3, directly don't go for taking 3, it won't works for internal rows and columns. Okay, taking C minus 1, it is going to substitute 3 now. And next if you observe row subscript values now, so you can notice 1 and 2 here. So that is from beginning row to the ending row, so we need to print values here. Again, what is the pointer we have for beginning row? M. Yeah, what is M value now? 1. We want to print values from 1 only, right? Okay, 1 only. So up to where we should print up to the ending row. What is the ending row pointer? So that is R. R value is 3. So if you take stop value as 3, it runs up to value 2, right? So means now we should run the loop for so generating so the row position values here, okay? Row subscript values. So after running so that loop, after running the loop, that variable values we need to substitute in the row subscript here, okay? So that we are going to get so the last column values. After that, it's not required to work with the last column, right? Okay. So we need to update the ending column pointer to the so previous one. It's not required to work with the last column. We need to update so the column pointer by 1. On updating so the column pointer by 1, C value becomes so 3. Okay. So let us complete this process now. So that is for IN. Earlier we taken loop for generating column position values, index values. Now we are taking so the loop for generating row position values. M comma R. So print array of so we are running loop for rows, right? That's why I'm collecting so those row subscript values here. So next afterwards last column it's fixed, we'll get with the help of C minus 1 and then is equals to space. In between values we need to add space. Okay, so after that it's not required to work with the last column, right? Okay, we need to decrement column variable value by 1, so becomes 3. Okay, so I hope you understood. So fine. Next, let us move on to the next one, third loop. These two are so very important. Okay, reverse loops. So you feel difficult when compared to the normal forward direction loop. So observe carefully, everyone. So what position values we need to print here? Okay. So let us check now. So 20, 21, and 22 position values has to be printed, but not like this. Okay, 9, 10, and 11 form. You should print so in this form, that is 11, 10, and 9. Okay. So here, observe the 11 value position here, it's 22. So 10 value position, 21. So 9 value position, it's 20. Okay. So now also you can so understood observe one thing. So that is row subscript value is fixed. So that is true. This is the last row, right? What is the last row pointer? So that is R. R value is 3. So from 3 we can extract so the 2 with the help of so R minus 1. I hope you understood with the help of previous one. So you can easily design it. And next of all, we should generate the loop for so the columns now. Okay. So it should generate values from the last column to the so beginning column. From the last columns to the beginning column, whatever it may be. Okay. So here it should start generating so the column values from 2 to 0, 2, 1, 0. These values has to be generated. What is the column pointer we have for last column? That is C. C value is 3. So it should start from, so we should start generating values from 2. Means loop we should start, reverse loop we should start from C minus 1. Okay, so that it start generating values from 2. And it should generate values up to the beginning column. So means if you take minus 1, okay, it works for this row. But what about for internal rows and columns? Okay. So we should run up to the beginning column, right? What is the beginning column variable value? It's 0. If you take so beginning column n variable as it is in the stop position, you know, if stop position value is 0, it generates values up to 1 only. Okay. So actually in the stop position, we should have minus 1 so that so it is going to generate values up to 0. For that sake, so n variable value we should not take as it is. If you take n minus 1, 0 minus 1, it becomes minus 1, right? So that it is going to generate values up to the 0 now. And don't forget to change the step count value. So on substituting so those subscript values here, okay, so the column subscript values, we can print the last row values. Okay. After that, it's not required to work with the so last row. We can so move on to the previous row, right? Okay. It's not required to work with the last row. Last row pointer. So variable value we can decrement so by 1 here. So that is you can update to 2. Okay. So let us complete this process now. First of all, so for I in range of mm, so what I said, C minus 1, we need to start from 2 and next up to 0 we should generate. If you take n, it generates up to 1 only. If you take n minus 1, it becomes minus 1, it generates up to 0 and don't forget to change step value minus 1. Otherwise, it won't work. Okay. Next, print array of. So we are generating so values indexes here for columns, right? Okay. Row subscript, it's fixed. Last row that is r minus 1 and the column subscripts we are getting here and is equals to space. It's not required to work with the last row. Okay, we can update it to the so 2 next and the last loop here. Okay, so that is we need to print the value 5 here. Okay, actually so the value 5 position is 1 0 here. By just taking so that position you cannot understood okay easily how to print it, what are fixed and what subscript values are changing here. So that's why just for understanding, so I'll take one more value also, that is 1. We should print so the first column values in reverse direction, right? So value 1 is present in 0 0 position. We are not going to print it, already it's completed, just for understanding. Okay. So I'm taking this. Listen now. Now you can observe, we can understood one thing here. So that is column subscript is fixed. So that is 0 and column subscript is fixed. That is 0 beginning column. So what is the beginning column? So pointer in, right? Okay. We should take n variable in the column subscript. And now we should focus on generating so the row subscript values. It is changing. So from 1 to 0 means reverse loop here. Okay. So means ending column to the beginning column, ending row to the beginning row, we should move on here. Okay. What is the ending row pointer here? So it's R. What is R value? 2. We should start generating so values from 1 here. Okay. Means again here, just now you observe the reverse loop for columns. Okay. The similar format it works now. So we should take loop as R minus 1. We should start with R minus 1. So again, if you take m value as 1, it works for only, it won't works actually. So r minus 1 means it's starting with 1, right? Okay, it won't works. That's why you should run loop up to the m minus 1 so that it works for at least one value. So that is one value is going to be generated. Okay. So those values on substituting in the row subscript, we can print this first column. Okay. After that, it's not required to work with the first column. We need to move on to the second column, right? We should update n pointer to the 1. Okay. So this is what required here. So let us complete this one now. So for I in range of r minus 1, next of all, so m minus 1 and minus 1 print array of, so row subscript values we are generating here, and column subscript it's fixed, beginning column and is equals to space. And after that, it's not required to work with the first column. We should update into the first position. Okay, first column here, and value becomes 1. With this updated, so m and n, r and c values, again loop is going to be repeated. It goes for printing internal rows and columns. Okay, I'll show you that. So, but before to that, observe what is the output we are getting now. Check everyone. So we are getting 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. Okay, again, so we are getting so the 6. So what is the reason for getting so the 6? I'll explain now in detail. So all of you listen now carefully. So that's why it is better to take the rectangular matrix. Okay, with the help of square matrix, you cannot understood. So this thing here, the rectangular matrix, you can understood the logic clearly now. So let us see how it is working, executing, okay, in the next iterations. What is m value now? It's 1. What is r value now? It's 2. And so n value is 1 and c value is 3 now. So both are true. It is going to repeat this loop now. So n value is 1 and c value is 3 means it is going to generate values, so 1 and 2, right? So means for what is m value now? 1. So what are the I values we are going to get here? 1 and 2, right? Okay. So means 1, 1 and 1, 2 position values are going to be printed. Okay. That is 1, 1 and 1, 2 position values, 6, 7 are printing. So here you can understood this thing. So previously we designed this loop for printing so the first row values, right? Same loop is printing so the internal row values now. Okay. So this is becoming possible only because of working with the so variables now. Okay, if you taken so only for values, it is not going to be printed now. So afterwards, as okay, m variable value increments to 2, and so let us see whether this one works or not. M value is 2 and r value is 2. It won't repeats actually. So start and stop values are same. Okay, here you can understood one thing. Okay, when we should run actually, so this inside part of while loop, whenever so these kind of two condition becomes true, right? Okay, but here, so if any one of the condition becomes false, it should stop the processing, right? So now you can clearly understood here. So the m less than or condition so failed here, but although it is going to be repeated, so the next loop. So the reason for that one is here you are observing so 3 rows, so 4 columns matrix here. Okay, so less number of rows and more number of columns matrix, right? So I'll show you. First of all, observe this. C value, okay, fine. This loop it is not going to be repeated. C value it is going to be decremented to 2. Okay. Now here it is going to repeat. So this loop or not, let us check now. C value is 2 now. 2 minus 1, it's 1. N value is 1 now. 1 minus 1, it's 0. So means loop it is going to be repeated for at least once. R minus 1 means 2 minus 1, 1, and so I value is 1. 1, 1 position value, so that is 6 is printing here again. After, so means this reverse columns, reverse loop for columns, it's printing now. So why it's printing again means, so here in this matrix, we have less number of rows and more number of columns, okay? The type of rectangular matrix we are observing. So that's why this loop is repeating here, okay? So now we should avoid repeating this loop. Okay, in order to avoid this, okay, we have one condition. So that is with the help of a row loop condition. So we can keep check for executing. So the reverse columns loop. Okay, columns loop reverse one we can stop it. Okay, because here we have less number of rows, right? Okay, so once if this one becomes this condition becomes a false, okay, it's not required to evaluate this. That's why I'm keeping so this one inside this condition. If m less than or, okay, then only we should run this loop. Now you can check. So 2 less than 2, it's false. Now it is going to be not repeated. So this one. So observe output now. You're not getting so the 6 also. Okay. So like this, we have one more type of rectangular matrix. Now you are showing low number of rows and more number of columns, right? Okay. Another rectangular matrix called we have more number of rows and next of all a few number of columns. Okay. In that scenario, we observed reverse rows loop, right? Okay, last loop. It is going to be repeated. Okay, so for avoiding that, we should add this condition here. Okay, that is n less than so c. Okay, so here I'm not taking so that example. Okay, so just remember this. We have two types of rectangular matrix. Okay, if we have so less number of rows. Okay, this one helps you to avoid printing so the column values repeatedly. If we have so the less number of columns, okay, this condition helps you to repeat the reverse row loop values. Okay, so that is the thing here. Now let us move on to the lead code platform now. So program, let us see now. See here what is given is a matrix variable given, and we need to return the list of integers from the method here. That is in work. So Jupyter Notebook platform actually, so I printed all the results onto the output screen, right? I didn't work it with any functions, but here, so we need to work with the functions, right? So from the function, we need to return the result, that too in the form of list of integers. That's why what I did here, I taken one result array here, okay? Instead of printing, so I'm adding all the spiral matrix results into the array with the help of append method. Observe what there is the only change you can observe here. Okay. Apart from that, everything is same. So just all the spiral matrix results I'm collecting here. Okay. So after collecting, finally I am returning so that array here. Okay. So you can check whether so it works or not now. Yes, it's working. You can check. Yes, fine. That's it. So this is a spiral matrix program. I hope so. Spiral part 2 is printing reverse form of spiral. So try for it. Okay. So you can after collecting so the spiral matrix values into array, you can reverse it. Okay. So here are strategies. Okay. Try for it. Okay. And so go for executing so those programs. I hope so each and everyone understood this. Okay. So thank you. Thank you everyone. Let us meet in the next video. Okay.